This is Module 3, Lesson 6, and actually 7, on angle-angle triangle similarity. We're using informal arguments to establish the angle-angle criterion for similarity of triangles, okay? Standard 8GA5. In other words, you're going to present informal arguments to demonstrate triangles are similar using angle-angle similarity, and we're going to talk about that. This is from Eureka, Module 3, Lesson 10. In your workbook on page 114. The lesson summary of this is two triangles are said to be similar if they have two pairs of corresponding angles that are equal in measure, okay? Two pairs of corresponding angles that are equal in measure. And guys, this is called angle, and you'll see it written this way a lot of times, angle-angle similarity. It's to prove triangles are similar. Or they will spell it out. They will say it is angle-angle similarity. And what we are proving is that triangles are similar. If they're similar, they have the same shape, but not the same size. Not necessarily the same size, okay? Now it says, are the triangles below similar? Present an informal argument as to why they are or are not similar. Now, we know that if two figures have the same shape, that means they would have the same corresponding angle measures. Let's look at angle A and A prime. See how they're both 31 degrees? Okay. So we've got angle A is congruent to angle A prime. How about B and B prime? Those are the same, aren't they? Angle B is congruent to angle B prime. Well, if the third angle is also congruent to each other, guys, then it's going to have the same shape. It may not be the same size, but it'll have the same shape. These two are triangles. I have two angles in this triangle. How could I find the measure of that third angle? We know from triangle sum theorem that the three angles in a triangle add up to 180, right? So angle A plus angle B plus angle C would have to be 180. Same thing for this one here, right? Okay. So let's find angle C. If those three add up to 180, I can add up these two angles, 31 and 103. And I get 134. But the three angles add up to 180. I've added these up. Let's subtract this from 180. 180 minus 134 would give me, and in your calculator, do this in your calculator so you don't make any mistakes, you would wind up with 46, right? This angle here is 46 degrees. Let's do the same thing with this triangle, okay? I have an angle that's 31, just like this other one. I have an angle that's 103, just like this other one. If I add that up, that's 134. If I subtract that from 180, what do I have? I've got 46. Well, look, that means these two have the same measure. And that makes sense. If two angles in a triangle have the same measure, and all the angles add up to 180, wouldn't that mean the third angle would have to have the same measure? Okay, that's what angle-angle similarity tells us. If two corresponding angles have the same measure, then that third angle is going to have the same measure and the two triangles are similar. So these two triangles are similar. How do I know that? I know that because angle A and A prime is congruent and angle B and B prime is congruent. Those are similar. How do I know that? By angle-angle similarity. If you've got two corresponding angles that are congruent in two different triangles, then the third angle is going to be congruent. They're going to have the same shape. They're going to be similar by angle-angle similarity. Let's look at these two. Okay, these two are the same. Angle A is congruent to angle A prime, but B's are not congruent. Let's check the C's here, okay? I've got 103 and 31. 3 and 1 is 4, 134. If I subtract 180, minus 134. What do I have for an angle? 46 degrees. This was 46. Okay, so guys, the 46 doesn't match that. The 103 doesn't match that. I've only got one angle, one set of corresponding angles that are congruent. So these are not similar. Okay, why are they not similar? Only one set of corresponding angles are congruent. Okay, that's why this is not, these two are not similar. They're not the same shape. They don't have the same angle measures. Only one angle measure is the same. You gotta have two. Are the triangles shown below similar? Present an informal argument as to why they are or are not. Okay, remember our informal argument would be angle similarity. Let's check and see. Angle A and angle A prime are both 72 degrees, so angle A is congruent to angle A prime. Those have the same measure. Okay, B, I don't know what angle B's measure is. Why don't I check to see? Let's find it here. If I add 48 and 72, okay, I get 120. The three angles would add up to 180, so I know that the sum of these two is 120. I'd subtract that, and this angle is 60. Angle B and angle B prime are both 60, right? Angle B is congruent to angle B prime. So these are similar. How do I know these are similar? Two corresponding angles, sets of angles are congruent. So these are similar by angle similarity. If I know that two sets of corresponding angles are congruent, then I know that the two triangles are similar. Okay, now go to the next page, page 121. Go to page 121, and let's look at these. Are the triangles below shown below similar? Present an informal argument as to why or why not. Okay, well, let's see. Angle A and A prime are congruent. They're both 31 degrees, right? Angle A is congruent to angle A prime. Let's check these others. Angle B is congruent to angle B prime, right? I don't even have to check the other angle, do I? I don't. Because if I've got two angles, two sets of corresponding angles that are congruent, then the figures are similar. The two triangles are similar by angle similarity. How do I know this? I know this by angle similarity. That works for triangles, only for triangles, but it works for triangles. If two of the three angles are congruent to their corresponding two angles, then we know that the two figures are similar. Okay, let's try number 2 here. Okay, are the triangles shown below similar? Present an informal argument. Well, let's look and see. Angle A is congruent to angle A prime. Remember, we're looking for two sets of corresponding angles that are congruent. If so, the two triangles are similar. Angle A is congruent to angle A prime. They're both 64 degrees. Angle B, well, I don't know what angle B prime is. I can figure it out, though, because I know the three angles in a triangle add up to 180. So let's add these two up, 64 and 32. That's 96. 180 minus 96 would give you 180 minus 96. Grab your calculator if you don't have it, just to check it, because I don't want anybody winding up with something 10 off because they didn't carry the number right. That's 84, okay? This angle is 84 degrees, okay? Angle B and angle B prime are 84 degrees, so they're congruent, aren't they? I've got two sets of corresponding angles that are congruent. So I know that these are similar. These two triangles are similar. That means they are the same shape, not necessarily the same size. And I know that because I have those two sets of corresponding angles. That's called angle similarity. Okay, and now in your workbook, page 122, let's look at it. Okay. Remember, to decide if two triangles are similar, we need to see if we've got angle similarity. Let's see. Let's check to see what we've got here. I've got angle B, okay? I know that angle B is congruent to angle B prime because it's shown right there, right? B and B prime. Oh, nope, I don't have B and B prime, sorry. Which ones do I have? I don't have C and C prime. I don't have A and A prime. Okay, I don't have any matching angles. And this one only has one angle here, so even though the three angles add up to 180, I don't know what one of the other ones is, so I couldn't subtract and find out. So consequently, guys, we're dealing with a situation where we don't have enough information to decide if they're similar. Not enough information, okay? Doesn't mean that they are similar, doesn't mean that they aren't similar. It means I don't have enough information to decide. Let's look at number 4. Are the triangles shown below similar? Present an informal argument as to why they are or are not. Okay. Well, we're still looking for two sets of angles, two sets of corresponding angles that are congruent. Let's see, A and A prime. Yes, I got that. Angle A is congruent to angle A prime. They're both 31 degrees. Okay. B and B prime, no, there's nothing there. C and C prime, angle C is congruent to angle C prime. I do have two sets of angles that are corresponding and are congruent. So therefore, these two triangles are similar. And we know that because of angle similarity. Okay. And because they are similar, that means that they're the same shape, but not necessarily the same size. Okay, and then I've got one more of these down here we're going to look at. Remember, we're looking for two sets of corresponding angles that are congruent. This only works for triangles. This angle similarity. Okay, so let's try this last set here. Angle A is congruent to angle A prime. I don't have the B's, I do have the C's, so we need to find this other angle. I'm going to do it up here on this one. The three angles in a triangle add up to 180, so if I add up the two angles that are there, and I subtract that from 180, I can find the missing angle. Now, use your calculator so there's no problems with carrying ones and stuff like that. 180 minus 151 would give me 29. Okay, so the angle that's missing is 29 degrees. I've got angle C and angle C prime. Angle C is congruent to angle C prime, right? They're both 29 degrees. I have two sets of corresponding angles that are congruent. A and A prime are both 70. C and C prime are both 29. If I've got triangles, that means that the two triangles are similar. I know they are similar because of angle similarity. Okay? Whenever I've got two sets of corresponding angles that are congruent, the 70 and the 70, the 29 and the 29, I don't even need to check the third angle because I know they add up to 180. I know those would be the same. I can prove the two figures are similar because they have angles in there that are, their corresponding angles are congruent. Similar means that their angles are the same, their corresponding angles are the same, their sides are proportional, okay? Now, one more I want you to look at, and this is actually in your workbook on page 125. And we're going to alter this to deal with what we want to do with it, okay? So it's not, don't pay attention to what's written here. They're wanting to know if these are similar. That we are going to do. If I have this diagram here, and notice I have triangle ABC, or A, these are my primes. This is my image, this is my pre-image, okay? If these two lines are parallel, can I prove that these two triangles, the small one and the big one, are similar? Well, let's look at this and see, okay? First off, angle A is part of both of those triangles, isn't it? Angle A is on both of them. So angle A is congruent to angle A. I've got one of them, okay? Now I need another angle. Let's look at this angle and this angle. If you've got patty paper and you know these lines are parallel, you can draw this angle off and translate it down here. You're going to see that it maps onto this one and they're the same measure. If you're not sure, guys, think about what we know about parallel lines and a transversal. If I consider these to be parallel lines and this is a transversal, think about what we talked about in the red lights in town. If we are looking at these red lights, you've got this angle is in the same relative location as this angle, right? Your bug splattered on your windshield, you're not going to see Cape Pasa, you're not going to see Bank of St. Francisville at this red light. These are in the same relative locations, the bottom corner on these intersections. So if they're in the same relative location, they're called corresponding angles. If the lines are parallel, corresponding angles are congruent. So angle C is congruent to angle C prime. Right there, that tells me that these two triangles are similar, and they're similar by, how are they similar? By angle similarity. Now I'm going to show you something. There's also a way to prove this third angle is similar, is congruent. Look, guys, if these are my two parallel lines, and here's my transversal, running through them. Whoops, didn't do too good drawing there, did I? Okay, this angle here and this angle here are also corresponding angles. They're in the same relative locations at these intersections, and they would be congruent because the lines are parallel. So you can prove all three of them congruent, actually. When you're dealing with a situation where you've got parallel lines and you've got a triangle within a triangle, then the two triangles are similar, okay? Now we've talked about all this angle similarity here. We've gone through how to use angle similarity to prove that two triangles are similar. Angle similarity only works on triangles, but it can prove that two triangles are similar using two corresponding angle pairs in each triangle.